Hello everyone, good morning. Today's topic is index numbers. Contains introduction, definition, characteristics, uses, problems, classification, methods, value index numbers, chain index numbers. These contents we will discuss today. What is index number? An index number is used to measure the relative change in price, quantity, value, or some other item of interest from one time period to another time period. Mainly, index numbers are used to measure the relative changes in phenomena, which are nothing but price, quantity, value, or some other item with respect to time from time to time. How the variable is changing from time to time, we will measure by using index numbers. A simple index number measures the relative change in one or more than one variable. What is an index number? An index number measures how much a variable changes over a time. In this, we will calculate the index number by finding the ratio of the current value to the base value. According to Ronald, index numbers are quantitative measures of growth of prices, production, inventory, and other quantities of economic interest. What are the characteristics of index numbers? There are many other characteristics. Few of them are index numbers are specialized averages, and index numbers measure the change in the level of phenomena. Mainly, we use index numbers to measure the changes in the phenomena. Phenomena is nothing but a variable. Index numbers measure the effect of changes over a period of time. What are the uses? To frame a suitable policies, we use index numbers. Based on the index numbers, how much variables are changing from time to time. Based on those changes, we will frame suitable policies. They reveal trends and tendencies. Index numbers are very useful in deflating. Classification on index numbers. Price index number, quantity index number, value. These are the types of index numbers. Methods of constructing index numbers. In index number, there are two types, weighted index number, unweighted index numbers. In weighted index numbers, there are two types, weighted aggregate index numbers, weighted average of price relatives. In unweighted index numbers, there are two types, simple aggregate index number, simple average of price relatives. Simple aggregate index number. It consists in expressing the aggregate price of all commodities in the current year as a percentage of the aggregate price in the base year. As earlier we have discussed how we calculate index number. We calculate the index number by finding the ratio of the current value to a base value. This is the current value. Current value is denoted as P1 and base value is denoted as P0, which comes under unweighted index numbers. It consists in expressing the aggregate of prices of all commodities in the current year as a percentage of aggregate price in the base year. P01 is nothing but index number of the current year. P1 represents the total of the current year's prices of all commodities. P0 is nothing but base year prices of all commodities. For example, in this example, we can see commodities, different types of commodities. Sugar is measured in quintals, milk is measured in quintal, oil is measured in liter, wheat in quintal, clothing in meters. Commodities are measured in different units, quintals. Sugar, food items are measured in quintals or kgs, etc. Oil is measured in liters or milliliters, etc. Clothing is measured in meters. These commodities are measured in different units. These are price in base year, these prices for current year. Based on prices of current and base year, we will calculate index numbers. Simple aggregate index number. We can see the solution here. Price in base year. Base year is represented as P0 and current year is represented as P1. Total of prices of all commodities in base year, and this is the total of prices of all commodities in the current year. The formula for simple aggregate index number is P01. P0 is nothing. P01 is nothing but prices of commodities in the current year, equal to total prices of all commodities in the current year divided by total prices of all the commodities in the base year into 100. Index numbers are represented in the form of percentages. So we will calculate as a percentage. By dividing, after simplification, we will get 134.45. It means the price in 2008 were increased to 34.45%. Coming to simple average of price relatives. The current year price is expressed as a price of relative of the base year price. These price relatives are then averaged to get the index number. The average used could be arithmetic mean or a geometric mean or even median. These average relatives are calculated based on the arithmetic mean or geometric mean or median. We can use either of them. Price relatives are denoted, simple average of price relative is denoted as P01 equal to, this is the formula for average of price relatives. Summation P1 by P0 into 100 by capital N. We know what is P1. P1 is nothing but price of all the commodities in the current year, and P0 is nothing but prices of all commodities in the base year. As a percentage, we will represent index numbers in the form of percentages, where capital N is nothing but number of items, total number of items. When geometric mean is used, average of price relative is log P01 equal to summation log into P1 by P0 into 100 by capital N. This is the formula to calculate simple average of price relatives. We have seen in the previous slide, in unweighted index numbers, I'll show you once again. In index numbers, there are two types, unweighted index numbers, weighted index numbers. In unweighted index numbers, simple aggregate and simple average of price relative. These are two types. Those two types are seen in this slide. This is the simple aggregate method, and we have discussed a problem also. This one is a simple average of price relatives. The next one is weighted index numbers. These are those index numbers in which rational weights are assigned to various chains in an explicit fashion. Weighted aggregate, in weighted aggregate index numbers, there are various formulas. Based on these formulas, we can find weighted aggregate index numbers. These index numbers are the simple aggregate type, with the fundamental difference that weights are assigned to the various items included in the index. Based on these formulas, we can find weighted aggregate index numbers. The first one is last year's index number. In this method, the weights are determined by quantities in the base year. In this method, the weights are considered as quantities in the base year. Whereas in formula for last year's method, P01 equal to, as usual, P01 is nothing but price index in the current year. Whereas in past year's method, the weights are considered as quantities in the current year. In last year's method, weights are considered as quantities in the base year. In past year's method, weights are considered as quantities in the current year. Coming to Drawbish and Bowley's method, weights in this method, the weights are considered as arithmetic mean of last year's and past years. Then we will get the formula as P01 equal to, this formula is last year's index number and this formula is past year's index number. Okay, Drawbridge and Bowley's method is the arithmetic average of last year's and past year's index number. We get the index number suggested by Drawbridge and Bowley. Coming to Fisher's ideal index number. Fisher's ideal index number is the geometric mean of the last year's and past year's. In Drawbridge, the arithmetic mean of last year's and patches. In Fisher's index number, we will get index number as the geometric mean of last year's and past year's. You can see the formula as the square root of geometric mean is nothing but the nth root of their product. Here only two products. We are considering two products, last year's and past year's formulas. Square root of last year's formula into past year's formula into 100. Whereas in Marshall-Edgeworth method, the formula is in Marshall's Edgeworth method, we will consider the weights of both the base years as well as current year. We will consider numerator consists of an aggregate of the current year's prices multiplied by the weights of both base year as well as the current year. In base year, this and current year, in both the numerator and numerator, we will multiply with base year quantities and current year quantities. Whereas in Kelly methods, this Kelly method is suitable for fixed weights. We have seen 6 formulas: last year's, past year's, Drawbridge, Fisher's and Marshall-Edgeworth. These 5 formulas is suitable to find out index numbers for both weights, both the years of weights. Whereas in Kelly's method is suitable for fixed weights. It is not suitable for both the weights of current year as well as the base year. It is suitable for fixed method. This is the formula. We can see the formula. We have given items, prices, production, price, production. 2002 is represented as base year and 2007 is represented as current year. This is base year prices and quantities. This is base year prices and quantities. Based on the formulas, we will calculate. After that, value index number. Value is the product of price and quantity as a simple ratio is equal to the value of the current year divided by the value of the base year. Value index number is nothing but ratio is multiplied by 100. The product of prices and quantities in the current year divided by product of prices and quantities in the base year into 100. These are the types of index numbers. These index numbers are very useful to measure the changes in various phenomena. Thank you.